Okay, let me tell you a secret. Motion is not just about speed. It is also about impact. For example, why does a bullet do more harm and more damage than a big soccer ball? The reason for that goes to momentum. So what is momentum? The official definition that we will be using is this. Momentum is how hard it is to stop a moving object. Mathematically, we can calculate it by using the formula P equals mv. So what are these symbols? You know two of them, most probably, and you can infer the third one. P is the momentum. M is the mass, and V is the velocity. The units are also familiar to us. Mass is in kilograms, velocity is in meters per second. Momentum, on the other hand, we can infer it from looking at the units of the other two quantities. So, when we want to get the momentum, we multiply mass by velocity. So what this means is that the units also multiply with each other. So the unit of momentum is literally kilograms, meters per second. So let's see how these units interact, or how these quantities interact with each other. When we look at the formula itself, we see that when we double the mass, there's a direct relationship between momentum and mass. So when we double the mass, the momentum also doubles. And this makes sense, because think about it. Suppose you have a soccer ball rolling at you at 2 meters per second versus a large boulder that is rolling at you at also 2 meters per second. It is obviously going to be harder to stop the bigger ball as opposed to the little soccer ball. Similarly, when we look at the formula again, when we double the velocity, the momentum will also end up doubling. And that goes back to the idea that velocity and momentum are directly proportional. So this also makes perfect sense. Think of another soccer ball rolling at you at 2 meters per second versus another soccer ball with the same size and same mass that is rolling at you at 4 meters per second. Of course, it's going to be harder to stop the faster soccer ball as opposed to the slower one. And this makes sense if you think about your PE sessions where you're playing football and there's someone shooting the soccer ball at you. The faster it is, the more you want to brace yourself for impact. So let's think about what happens when we double both mass and volume and velocity. So momentum is mv, and we are doubling the mass and doubling the velocity. What do you think happens to the momentum? Well, given that when the velocity increases, then that will double the momentum, and when the mass increases or doubles, then that will double the momentum as well. Then we end up with doubling the doubling of the value of the momentum. So that means the momentum ends up being quadrupled. And again, this makes perfect sense when we think about it physically. Think of the same soccer ball rolling at you at 2 meters per second. It's going to be 4 times as hard to stop a larger or a twice as larger ball that is rolling at you at 4 meters per second. Now that we see the relationship between mass on momentum and velocity on momentum, that it's a direct relationship, what about the relationship between mass and velocity? How do they affect each other? Well, to answer this question, we're going to need to do a little rearrangement of the formula. We're going to bring the velocity to the other side, And when you bring something to the other side, you cannot just bring it as it is, you have to flip its sign. So now it becomes P over V equals M. Knowing this, now we can see that when the velocity increases, the mass is going to have to decrease. So think of it this way, P over 2 versus P over 4. The velocity here is 2 and here it's 4. Now that the velocity is increasing, then that's going to make the mass smaller because P over 2 is definitely larger than P over 4. So mass decreases as velocity increases. And obviously, it's true the other way around. When the mass increases, velocity is going to decrease as well. And to think about this physically, let's consider a big boulder. The big boulder is rolling at a slow speed, let's say at 2 meters per second. It's quite difficult to stop a rolling boulder, especially if it's rolling at 2 meters per second. So my question is this. If I want to keep the momentum the same, I want to maintain the same momentum, but I want to decrease the mass, what do I need to do to make sure that the momentum of the smaller object is the same as the momentum of the larger object? Well, given that decreasing the mass must mean that the volume is increasing, so that's exactly what we're going to do. Having a smaller mass means that the velocity must increase. So to keep the same momentum for a smaller object, you're going to have to make it go much, much faster. It's going to have to increase its speed, depending on the mass of the larger object. So if we want to, let's say this is a 2 kilogram object, then we must double the velocity and make it go to 4 meters per second if this object is 1 kilogram heavy. The other way is also true. Suppose you want to keep the same momentum, but this time you want to decrease the velocity. What do you have to do to maintain the same momentum? Well, if you want to decrease the velocity and keep the same momentum, you're going to have to increase the mass. So you have to get a larger object even, that has double the mass maybe, so that you can decrease the velocity into, let's say, 1 meters per second. And this makes sense because it's going to be equally difficult to stop this object versus stopping this object.